So x to the 6th over x squared. And just kind of look along. You're going to get notes here in a minute, but I want us to just kind of get a concept of what we're looking at here. So we have 6 x's in the numerator. And 2 x's in the denominator. So we can cross them out one at a time, right, with division. I can take this one, and I can take this one. So how many x's am I left with? 4. Technically, that's over 1 because I factored everything out, and I'm left with 1. So we would write that x to the 4th. So if I switch it and put x squared in the numerator, x to the 6th in the denominator, looking at it in the same way. I have 6 x's. And I cross them out one at a time. I'm still left with 4 x's, but where are they left? Yes. So that's 1 over x to the 4th. So division, what it's really about is where do you have variables left when you take out the common ones, okay? So anybody see a shortcut? Because when we multiplied them, we could do a quick adding the exponents. Subtract the exponents. Okay. So x to the 6 minus 2, and that makes x to the 4th. That works. So if we do the same thing here, x to the negative 4. When we simplify these, we do not leave negatives. So what the negative exponent tells me is it tells me I have more x's in the denominators. So to fully simplify that, I move that to the denominator, so it's now positive. Okay? So that's why you end up with negative exponents when you subtract them, and then you simplify it to make it positive. Okay? So we're going to be working with subtracting our exponents, and we're also going to be taking a look at some negative exponents, how those work out today. Okay? So based on what we just did, take a look at the first 2 problems, problem 1 and 2. So the quotient of powers, we subtract the exponents. Just like you said. Okay. We'll get to the power of a quotient, and we'll get to the 0 exponents when they come up in a problem. Okay? So if we simplify this first expression, thinking in terms of, I'm going to just write out how many we have, just to show for the notes. I have 5 6's in the numerator and 4 6's in the denominator. So again, if I go through that pattern, crossing them out one at a time, I'm left with 1 6. Now, if I use my rule that says to subtract the exponents, 5 minus 4 equals 6 to the 1. And that's exactly what we have here, 1 6. Okay. So on number 2, we have 4 x's up here and 2 here. If I cross them out one at a time, I'm left with 2 x's. Using the rule, again, definitely want to try to work with that. 4 minus 2 saves you a lot of time, so you don't have to keep writing all extending those things out to cross them out to simplify that. So it's definitely helpful in my case. Okay, so when we have ones like this, if I use my rule, I'm going to have r to the 3 minus 3, and I'm going to have t to the 2 minus 4. So that becomes r to the 0, t to the negative 2. So let's take a look at what's really happening with those variables, okay? I have 3 r's, and 2 t's in the top. I have 3 r's and 4 t's. Okay? So the 0 and negative exponent, as we initially start working with it, it's helpful to have a reference for why it's happening. So I cross out the r's one at a time. I have no r's left, correct? So that's just 1 now. It's the equivalent of 4 over 4 is just 1, right? Okay. I cross out the t's one at a time. I have 2 left, but where are they left? Exactly. So I have no r's left. I've divided them all out, so I have 1 over t squared. So when you have a negative exponent, you move it to the opposite place, so that way it's now positive. So that negative exponent tells me that I had 2 more t's in the denominator instead of on top. Okay? When we're looking at fractions with numbers like this, I treat this as 2 separate problems. First of all, I have a number to deal with on simplifying, and then I have exponent rules with the variables. So 12 over 36 is one number. Right. So that would be 1/3. My variables, remember I have 1 in there. So I'm going to have 5 minus 1. So that's really 1/3 n to the 4th. So your fraction with a horizontal line, the end of the 4th behind it, in the middle, or end of the 4th over 3. Because that's really where I have 4 more n's up here than I do down there. Okay? So, again, number, then variables. So I have 32 over negative 8, and then I have my variables. So what is 32 divided by negative 8? Negative 4. All right, so my variables. For x, 3 minus 1. For y, 2 minus 1. For z, 5 minus 2. So doing that subtraction, I'm left with x squared, y to the 1, z to the 3rd. All right. So on number 6, there are 2 rules going on. If, but really not. So we can't subtract these exponents, 7 and 2, because those are different variables. So the power rule. So this is that second part to this. That exponent of 2 is going to get applied to the numerator and denominator. Okay? So we have 4p to the 7th squared over 7r squared squared. So you have 2 different problems. So 4 squared is 16. What do we do with the power to a power? Multiply. So that's going to be p to the 14th. Because remember, I have 2 groups of p to the 7th. So 2 groups of 7 make 14. What's 7 squared? 49. And r to the 4th. Because we have 2 groups of 2 on the r. And then there's nothing we can simplify. That's your final answer. Okay. Well, on 7, the 0 exponent says we have nothing there, right? So anything to the 0 power is 1. Okay. So again, keep in mind, I'm going to do very simple. Keep in mind, this is division, right? And if you divide everything, you're still left with 1. So that's what's happening. The rule, and that's why. Because you divided, that is the result of dividing everything, that 0 power. So anything to the 0 power is 1. All right. Number 8. We subtract exponents when we divide, right? I'm going to go ahead and do that. F to the negative 7 minus 4. Negative 7 minus 4 is negative 11. The rule on exponents is we never leave them as negative. So we need to flip it. So then we move it 1 over f to the positive 11. So even though exponents are negative there, I'm still going to use the rule that says to subtract them. Then at the end, I do what I need to do to make it positive. How are we doing? Not too bad? Pretty good? Okay. Oh, goodness. Okay. So I'm going to look at 9 in terms of 15 over 5, and then my variables. Fifteen over 5 simplifies to 3. Okay. Now my variables. X to the 6 minus 1. Y to the negative 9 minus a negative 11. So I'm ignoring the fact that they're negative. I'm just working with the rule with the numbers I have. So it becomes x to the negative 9 minus a negative 11 is what? And voila, no more negative. It took care of itself. I just used the rule, subtracted the exponents, and that's where I ended up. Okay. On number 10, ones like number 10 can be difficult to work with, especially if there is any kind of a number in front. We have a whole negative exponent right here. So do we work with it as it is, or do we move it so that negative 4 becomes a positive 4? Which way you want to do it? Either one, honestly. You want to make the negative 4 positive? Yeah. Okay. So that means that whole piece gets moved. So I have j to the third, k to the third already down there, j to the negative 1, k to the third, and it's now positive 4. So by moving that whole piece, the only thing I've changed is the negative 4 outside is now positive 4. Okay? So I've got power to a power right here. So I'm going to take care of that first. So negative 1 times 4, negative 4. 3 times 4, 12. Now, I have the multiplication rule, so I just add the exponents. Three on j, 3 plus a negative 4 is a negative 1. 3 plus 12 for k is 15. Okay. I still have negative and exponent. So if the negative was in the top, we'd move it to the bottom. If the negative's in the bottom, where does it go? To the top. So that becomes j to the 1 up here Okay, of 15. So we're going to take this and move it up the other direction. So it's now a positive exponent. Bless you. Okay. It's still going to work out the same way, no matter which way you do it. Okay. Oh, the whole fraction is negative. So first thing I'm going to do is I'm going to make that negative 5 a positive 5. And to do that, I just flip the entire fraction. So leave everything the way it is. Q r to the third is now on the top. Q to the negative 1. R to the third. But the exponent outside is now a positive 5. Okay, two rules going on here. I've got a division rule going on, and I've got a power to a power rule going on. So I would honestly work inside first, because then you're simplifying, and then deal with the 5 that's outside. So, for Q, I have 1 minus a negative 1. For R, I have 3 minus 3. So 1 minus a negative 1 is 2. 3 minus 3 is 0. Now, power to power. So Q, 2 times 5 is 10. I have 5 groups of 2. What about R? It's still 0, right? Because I have no groups of 5. So my last answer is just Q to the 10th, because anything to the 0 power is 1. All right, on 12. Again, I have a group of negative exponents. So I'm going to move that whole group to the denominator. Nothing changed inside the parentheses. The only thing I changed is that exponent outside is now at positive 3. So use the power rule. See what you can come up with on this. All right, let's take a look. I don't do anything with the 5a squared b to the 4th yet. 2 to the 3rd is 8. 3 groups of negative 2 make negative 6. 3 groups of b make b to the 3rd. Now I'm in a multiplication situation, so I add my exponents. First, I multiply 5 and 8 to get 1 over 40. 2 plus a negative 6 make a negative 4. 4 plus 3 make a positive 7. So the only thing I need to do is to move that a to the negative 4 to the top. So that's a to the 4th over 40b to the 7th. How'd we do? Okay. Yes. When you have more than one rule in the problem, and a lot of times you do with division, take care of one rule at a time. Don't try to do too much work at the same time. Okay? Okay, 13. Is that the same problem?
Yeah.
Is that the same problem?
Yeah.
Okay, we're done. Oops.